Okay, guys, so let's go over the notes I had you copy down the other day. So we're going to talk about the triangle congruency theorems today. So again, they're triangle congruency theorems, which means they only work for triangles. So if you do a pentagon, or a hexagon, or a quadrilateral, or any other shape, you're going to have to use that long method, where you have to list out all the corresponding congruent sides, all the corresponding congruent angles, okay? But for triangles, we're now going to have some shortcuts. Your first shortcut is the side, side, side congruence postulate. And so that's when you see three pairs of sides that correspond and match. So like we have one tick mark here, two tick marks here, and three tick marks here. Instead of listing everything out, now we can just shorten it down to saying that the triangles G, H, F are congruent. What matches G?
G.
What matches H?
Q.
And then R, 5, S, S, S. So that's all you're going to have to do now. Write the statement and tell me why. A lot less writing, isn't it? A lot easier, isn't it? I told you we weren't going to stick with that stuff for real long. I just had to teach you what it meant to be congruent first, then the shortcuts. Second one is side angle side. Okay. The important part of this is knowing that your angle is included. What do I mean by included? Okay, it's in the middle. See how C is in the middle of those two sides? Okay, it's like the cream in the middle of the Oreo cookie. You want it in the middle. So if you have figures in the order side, angle, side, side, angle, side, then you're able to say that they're congruent as well. Again, the order is very important. So we could say triangle CBA. What would be its matching triangle?
Yeah.
Good. 5
SAS.
S A S. Any questions so far?
No.
Okay, this one has S in the middle. So this time your side's in the middle. See how this is in between the two marked angles? And this one's in between the two marked angles. Okay, if you go in the order ASA, ASA, your two triangles are congruent by angle, then a side, then an angle. Okay. Now look at this one. This one's angle, angle, side, and this time the side is not in the middle, it's the non-included side. What does not included mean? Not included. Okay. So if you look at it this time, here's my two angles that match these two angles. Are my sides in the middle of those two circles? This would be in the middle of the circle. This would be in the middle of the circle, and it's not. Okay? So this time I would read the order angle, angle, side, angle, angle, side, and they would work. Your last one that you wrote down is your HL. And again, if you notice, it was capital letters, exclamation points, because it's for right angles, right triangles only. Why would it only work in right triangles? What's H stand for? Hypotenuse, and L is leg. Does every triangle have a hypotenuse?
No.
No, only the right triangles, okay? And don't forget your hypotenuse is the one located across from the 90-degree box. Okay, so if you have hypotenuses that match, and the leg would be one of your other sides, you can say that they're congruent by HL. So let's review. What are our 5 theorems we can use? SSS.
HL.
Mm-hmm.
ASA.
SAS.
Alright, so they're all the ones that work. Sometimes it's easier to think about the ones that don't work. So what doesn't work? Which one don't I have up there?
Huh?
AA. A. Does not work. Okay, AAA is not coming to tow your triangle away. AAA doesn't work. How about another one you don't see up there? Or if we say it the other way. What did I just write on the board? That's gonna be a good answer to a geometry problem. S.
Yeah.
It
Would
might
you
be.
want to write the answer on your test as S?
I
Okay,
mean-
or ass backwards. Is that really what you want to put on a test?
No.
Okay. They are known as. Okay. They don't work. Okay, just because you have two sides that match and an angle hanging out somewhere, it's not necessarily going to make the two triangles congruent, so we cannot use them. So if you can remember, AAA doesn't work, ass and ass backwards don't work, you should be pretty good. All the other combo deals plus HL work. So let's try. Remember this one from your previous set of notes? And we said that we didn't have enough information. Now we can say that they are congruent. Can anybody figure out which theorem it would be? Get a camera. I will tell you, yes, the third angles do work. Very good. But out of those theorems that we just wrote down, which one of them would prove to me that these two triangles are congruent? A, A, S. A, A, S. How come I can put an S here? No, because it's a straight line.
It's a side.
It's a side that what?
That has a line.
That they meet at, which means they both have in common, right? So it's the side that they shared. So it's congruent to itself, either reflects the property. So yes, that is the right answer. So we would write triangle SRP is congruent to triangle. What would match the S?
Q, Q or
Then R and P, 5, A, S. And that's all you gotta write now.
I don't get this.
Where am I losing you?
Like, you're just saying, like, side, side, side. I don't know what that means.
So it goes back to the theorem. So my theorem is, if I can show that triangles have matching angle, angle, and sides, it has to be in that specific order, okay? So if you're looking at this triangle on the left, I see this angle matches that, that's one angle. This angle matches that, that's two angles. And then you have the shared side, that's a side. So we have angles, angles, and a side that matches between the two triangles. That's enough information to say that they are congruent. So instead of proving we have 3 pairs of congruent corresponding angles and 3 pairs of congruent corresponding sides, if just these pieces match, mathematically, it's enough to say they're congruent. You don't have to do all the extra stuff. Does that make sense?
Well, yeah, I knew they were good, but the theorems, like, I don't know which theorem to do.
Okay, so it's, you look at the markings. All the curves are angles, all the tick marks are sides. So you just look to see. So I'm seeing an A, an A, and an S. And then I look over here, does it match? I see an A, and an S. That's how I know it's angle, angle, side.
What is the like A and A?
A is angle, S is side. Okay? They're shortened. Instead of, do you want to write by angle, angle, side? Or do you want to write AAS? It's like the same thing for segment addition postulate. We were calling it SAP. Same difference.
So is number 2 SSS?
This one?
what do you mean SAS?
Here I see SAS. I would agree with you. Does this one say SAS?
No.
No. Okay, what does this one say?
AS.
Okay. Do we have an ASS one?
No, we don't.
No, we don't. Does the order match? No. So are they congruent? Good night.
What's known as
You're behind Anaya, I believe.
So is number 3 AAS?
Very good. AAS, AAS. Okay, be careful. A lot of people want to jump for HL, which is why I put this here. Okay, it is not HL because you need an H, which I do have. Do I have any legs marked off?
No.
No, that's why I can't use HL, but I can use AAS. So let me go with names here. A, B, C, X, Y, and Z. We
Do we
would
have to
say,
give them names, or can't we just say what it is?
for this problem, I just want to give it.
I know, but like.
Not all the time.
On the test, do we have to?
I
give
will
them
tell
names?
you if I want you to. How about that?
So
Yes.
how can there be like two? You're like saying like A, and you're like naming what is like A, which stands for angle. and
This
like-
is an angle, this is an angle, this is a side.
Oh,
So like this angle matches that angle, that's one. This angle matches that angle, that's two. This side matches that side, that's three. Does that make sense?
Yeah.
Okay. So the triangle ABC would then be congruent to triangle XYZ. Questions? Don't forget to rate by A. Moving right along. Now this one's kind of funky. This one is overlapping triangles. So whenever you get overlapping triangles, I would suggest redrawing them. So redraw this one. Okay, here's my red one. This is an A. This is a B. This is an E. And there's a tick mark here and a tick mark here. I'm going to use a different color and draw the other big triangle in yellow. Okay.
Just keep each other.
Do you have any right angles?
No.
Remember, HL only works with right triangles. Alright, so now I redrew a yellow triangle and I redrew a red triangle. I see sides. Do I have enough information right now?
No.
No, but is there something I could mark there that's not currently marked?
The ones here.
Which one?
A,
The AE, right? Don't I have AE here and AE here?
Yeah.
yeah.
Didn't I color over it twice? It actually has a shared side. So why are they congruent? Right, so what theorem is that? SSS. So triangle BAE is congruent to triangle. What matches B?
B,
D. What matches A?
A,
Look at the A over here.
E.
What's in that spot? E. And then A. By S, S, S. And we'll do one more like this. All right, number 5. I see angles. Anything else I can mark?
Well, parallel,
The included side, okay.
but
And
then
I do have parallels. They're there for a reason. What if I extend them? Okay, and then I mark off here and here. What kind of angle pair are they?
I would say
alternate.
And what do we know about alternate interiors?
they're congruent.
Bingo. So are the triangles congruent?
Yeah.
By?
Right,
ASA.
AAS. See this side? Is that side in between these angles?
Yeah.
It's in between these two?
No.
No. Is it in between these two? So the side isn't included, it's after. So we would use AAS. Angle, then an angle, then a side. Angle, then an angle, then a side. And it's triangle WXY is congruent to what matches W?
Why is W first?
Don't I just call like it? Yep, you can pick anything first. Right, Y will go next. Okay, what matches this X?
Z.
Z, and then W. Okay, any questions? Yes, Claude.
I don't really understand this one and like the angles you're looking for, because why can't you just take like the parallel lines and use that as like a side?
Do you see tick marks on them?
No, but they're line thingies on there.
Right, and that just means parallel. So from the parallel sides, we got those extra angles, because we know when you have the parallel lines with the transversal, we have all those special angle pairs. Does that make sense? So parallel lines don't mean congruent. Parallel lines just mean parallel.
Okay.
Okay? Next one. What other information do you need in order to prove these triangles congruent? So currently I see a pair of sides. Is there anything else I can put in there?
Those parallel lines.
I don't have any marks.
We put transversal.
But do I have any parallel marks?
No.
You
Right.
have KS.
Yes. All right, I have a shared side. Okay, so I have a side here and a side here. All right, I need something else. Now, there's nothing else I can mark in there, but what one thing could I mark and to make them congruent? An angle. Which angles, Yusef? Okay, this would work. Okay. If I marked, and now there's two of those, so I have to use 3 letters. Angle RSK congruent to angle TKS, right? Then how would they be congruent, the triangles themselves? Which one of those 5?
Yes.
Side angle side.
Side angle side, good. Did anybody see something else they could have picked besides that angle?
So like, couldn't you make a square?
Okay, where?
T and R.
If you wanted to make a square here and here, right? Then yes, it would be HL with hypotenuse and the lengths. Very good. So if angle R and angle T are right angles, then it would be HL.
Wait, why is it angle instead of a triangle before that?
All we're doing is what other information do you need to make them congruent? So if I said these were congruent, then this theorem would work. Okay? If I said these were right angles, then this theorem would work. So I'm only looking for the missing information, not which triangles are congruent. If I erased all this, right, is there one other thing I could have done? Yeah. What if I said RK and ST are the same? If I made my sides congruent, which theorem could I have used? SSS. So there's 3 different answers you could give to this one problem. It's all on how you see it. Questions? Last one. Figure out which 2 are your congruent triangles. Yes, you're correct. It is. By which theorem, Cameron? Very good. Angle side angle. So triangle CAT is congruent to triangle C matches
G.
and A matches. Oh, God. Angle side angle. How come fin didn't work?
Angles on the
The angles.
Right. The angle is not included. Questions?